Welcome to this tutorial on dynamic range. Dynamic range is an essential concept for studio owners, but difficult to define in a single sentence. In fact, the term has several different meanings. Therefore, we're going to start with some examples. The human auditory system is designed to accommodate a range of sound pressure levels or volumes most useful to our survival, from the quietest sound pressure, such as the disturbance of long grass in the breeze, to the loudest, such as a nearby gunshot or approaching catastrophe. Humans can hear a wide but not unlimited range of volumes. The quietest sounds can be heard just above our threshold of hearing at 0 decibels, and the loudest just below our threshold of pain at 130 decibels. This range of sound pressure levels is referred to as dynamic range. Because sound travels in the air as a pattern of changing air pressure energy, decibels are a measurement unit for sound pressure levels, or SPLs for short. So decibels, SPLs and dynamic range are all about volume and loudness. When confronted by very loud sounds above 130 decibels, our auditory system is unable to cope. It simply has no way to represent them. Our hearing distorts and we may experience pain and short or long-term hearing damage. We call 130 decibels the peak level, and above it is clipping and distortion. Some sounds are too quiet to be heard. Our sensitivity is simply not good enough. But sometimes we can't hear quiet sounds because they are masked by unwanted internal noise. This noise could be tinnitus, a symptom of hearing damage that manifests itself as a perceived ringing or high-frequency tone, or it could be the noise created by blood pumping through the structures of the auditory system. Hold your hands over your ears to see what internal noise you can hear. We can draw a simple diagram showing the theoretical lower limit of human hearing, or silence, at 0 decibels, the noise above that, peak level and the threshold of pain, and distortion and clipping above that. The noise element is known as the noise floor. Our auditory dynamic range is between the peak level and the noise floor. To sum up, the dynamic range of human hearing is not between the loudest and quietest sounds that the human auditory system can accommodate. It is the difference between the loudest and quietest sounds that we can hear, or the range of sounds between the noise floor and peak level. Dynamic range doesn't just refer to human hearing. It can refer to any system that handles sound waves or to sound itself. The term dynamic range can be used to express the difference between silence and peak level, the difference between the noise floor and peak level, the difference between the quietest and loudest parts of a sound wave, and finally, the difference between the quietest and loudest sounds that a musical instrument or sound source can generate. If the dynamic range difference is large, it is said to be wide, and if it is small, it is said to be narrow. The relationship between the unwanted noise and the wanted signal or dynamic range can be expressed as the signal-to-noise ratio. For audio equipment, the noise floor will be the unwanted noise produced by the electronics. Signal-to-noise ratios are usually calculated from the noise floor level and a reference level. Signal-to-noise ratios are one of the specifications that are used to help determine the quality of audio equipment. A high signal-to-noise ratio is almost always desirable because it means the noise is quiet and the dynamic range is wide. A microphone's dynamic range is defined by its noise floor, its sensitivity to sound, and the maximum peak level signal it can accommodate. Most microphones use an arrangement of a moving diaphragm and magnets to convert the sound waves in the air into electrical signals. In simple terms, the maximum travel of the diaphragm defines its peak level, and the efficiency of its electronics and design define its noise floor. For example, the SE Electronics SE4400 has the excellent dynamic range and noise specifications we expect of modern capacitor mics. It can handle sound pressure levels of 130 decibels and its noise floor is at 17 decibels. The difference between these levels is its dynamic range. Audio processors such as compressors and EQ have dynamic range too. In general, professional devices will have better quality components and be capable of a wider dynamic range than cost-effective devices. This is especially important for devices that use valves or tubes in order to achieve the best possible signal-to-noise ratio. The dynamic range of a musical instrument can be defined as the difference between the quietest and loudest sounds it can produce. Unless the instrument has some underlying operational noise, such as an analog synthesizer or accordion or a pipe organ, there will be no noise floor. An acoustic guitar, for example, is essentially silent until it is played. The term dynamic range can also be used when talking about sound itself, especially music and conversational speech. Musical notes, pitch and words are not always sufficient to convey meaning. Dynamics play an equally important part. The dynamic range of a piece of music or conversational speech will be the difference between its quietest and its loudest moments. Classical music in particular is adept at utilizing wide variations in volume. We would say that such a piece of music has wide dynamic range. On the other hand, much pop music is performed and recorded to be loud all the time, so it grabs attention, and therefore is said to have narrow dynamic range. The script for this tutorial, with accompanying screenshots, can be found at projectstudiohandbook.com. And finally, please don't forget to subscribe to our YouTube channel or at the website to get instant notification of new videos as they are uploaded. And please do click on the ads of interest to you. We're a free resource and they help to pay our costs. Thanks very much for watching.